Let's take a look at the specific heat capacity. So you can see in the question, the specific heat capacity of when it's a solid is 2456 joules per kilogram per Kelvin. And when it's a liquid, we have 5107 joules per kilogram per Kelvin. And for a gas, we have 2904 joules per kilogram per Kelvin. Okay, now again, let's look at what these units are actually telling us. Okay, if I want to take 1 kilogram and increase the temperature of 1 kilogram by 1 Kelvin, I need 2456 joules. That's what the unit means, 2456 joules for 1 kilogram to increase by 1 Kelvin. Okay, now to increase the liquid by 1 Kelvin, if I have 1 kilogram of the material, I need a lot more energy. Okay, now for the gas, to increase 1 kilogram by 1 Kelvin, I need somewhere in the middle, 2904. So what this tells me then, when I draw my graph, so I need a little bit of energy, and the temperature goes up quite quickly. I only need a small amount of energy for a large increase in temperature. So it's energy and temperature. Now, after it's melted, now it's a liquid. This gradient is going to be a lot steeper, isn't it? Because I need a lot more energy for the same, sorry, that's a terrible line, for the same increase in temperature. Notice this temperature increase and this temperature increase are about the same, okay? But for the liquid section, I need much more energy than this because this number is so much higher than the solid one, okay? And so what these numbers are actually telling you is the gradient of the graph, okay? If you want to look at it in a little bit more mathematical detail, let's erase that. So we know that Q equals mc delta theta, okay? Well, in our graph, I've written it E and T, so I'm just going to change the letters, okay, but it's the same thing. Now, notice, let's assume in this I'm having 1 kilogram, okay, so I'm just going to put that equal to 1, and I get C delta T. So, rearranging that gives me C equals E over delta T, okay? So, what is my gradient though? If I have a straight line like this, well, I have my rise, again, a terrible line. I have my rise, which is the temperature, over the run, okay, which is energy. Well, that's the opposite here, isn't it? So I'm going to flip this equation upside down, and we have 1 over C equals delta T. This is my gradient, isn't it? Okay? So the gradient of the graph is 1 over specific heat capacity. So a high specific heat capacity means a small gradient. Now this is a little bit like what I just told you. I explained it a moment ago from a sort of physics point of view, but that's the maths of it, okay? So a high gradient will, a high specific heat capacity will give you a small gradient. So that's why this is a small specific heat capacity, so I have a steep gradient. Then the next section here, that's a very high specific heat capacity, so I have a small gradient, okay? So that's how this data will tell you important information about the shape of the graph, okay?